of your soil will also have a huge impact on the amount of water that's able to be stored by that soil. And in turn, then, the amount of water being able to be held within the drainage basin, and then also the flood risk. A sandy soil may have larger gaps between the particles and be able to hold more water. But as the interparticle distance gets less, such as in clay soils, for example, water may infiltrate more slowly. So this will affect how quickly our water reaches our channel and the lag time within our drainage basin. The good news is that we can use a simple key to help us determine the texture of the soil. We call this type of key a dichotomous key. You have a copy of this key in your handouts, so you will want to make sure that you've got it in front of you now, ready for the next part of the video. So we can actually try and find out the texture of my soil sample here by using this soil texture analysis key. Now again, I've tried to think about it ethically when I've taken my soil sample, taking it from the same depth down as maybe I did before. But what I'm going to do is I'm going to analyse my soil sample using this key and working through this flow chart. Now you have a copy of this chart in your handout, so what I would like you to do is follow through your flow chart as I analyse this soil. Okay, so the first thing on the key says put some soil in the palm of your hand, add some drops of water, so I've got a bucket full of water here, and work the soil with your fingers to break down any lumps until the soil is evenly moist and feels like putty, and you have a ball about the size of a golf ball. Okay, so that's about the size of a golf ball, right? Okay, so the next thing says, squeeze the soil in the palm of your hand. Does it remain in a ball? Yeah, it remains in a ball. I'm going to go with yes. Then it says roll the ball to form a sausage about 1 centimetre thick. Okay, so just going to roll it on the palm of my hand. And yeah, it forms a sausage. Then it says flatten the sausage between the thumb and the forefinger. So I'll do that next. And I guess some of this is quite subjective because I'm not sure how flat exactly I need to get this. But after that it says, does the soil form a flat ribbon before breaking? It's kind of flat and it's not breaking, so I'm going to go with yes. Is the soil ribbon less than 2.5 centimetres long before it breaks? So I guess it is more than 2.5 centimetres long before it breaks. So I'll go with no. Is the soil ribbon between 2.5 and 5 centimetres long before it breaks? I'm going to go with yes, it definitely has broken, and I don't think it's more than 5 centimetres. Okay, so the next thing says take a pinch of soil and add water to make it wet. Rub it between your fingers, and how gritty does the soil feel? So this is going to be my pinch of soil. I'll add some more water to it. And yes, it feels very gritty. So I'm going to go with, if I said very gritty there, sandy clay loam. So as we can see from this slide here, the soil that we've identified is sandy clay loam, and it sits almost in the middle of that scale. It's not really good at infiltration, but it's not really poor at infiltration like we'd expect clay soils to be. Now, it's really important to consider the time of year that you're taking your soil sample and how that might affect the results that you find. For example, in the summer, clay soils will crack and make the gaps between the clay particles bigger. And we said earlier that we expected clay soils, the gaps to be very close together, so the water wouldn't infiltrate very well. So there might be some seasonal variation within that. You also might find some of the categories on that flowchart subjective, and that's okay. And you might have disagreed with kind of, what I put my answer to in those categories, and we might have got slightly different answers, which might be a limitation of using this flowchart. One thing that's really important to do after you finish collecting your soil data is to wash your hands afterwards.